3. Pressure-temperature relationship. The sign. The gas volume is fixed. The relationship between pressure and temperature of a fixed mass of gas is investigated. So, when the gas temperature increases, how would the gas pressure change? Make your guess before the start of the video. Experiment 5B. Pressure-temperature relationship of a gas.
This experiment aims to find out the relationship between pressure and temperature of a fixed mass of gas at a constant volume. Plug a pressure sensor and temperature sensor into the holes of the stopper. Then, connect the sensors to a data logger interface. Wrap a flask with cotton wool. Then, put it in a laboratory oven at 150 degrees Celsius for about 20 minutes. Take out the flask from the oven. Stopper the flask with the stopper. Seal all the joints with adhesive tape to prevent gas leakage. Start the data logging program to record the pressure and temperature of the gas inside the flask. Note the PT graph recorded. What can you deduce from the graph?
The volume of the flask does not change, while the gas pressure increases with temperature. But they are not directly proportional. The PD graph is a strict line that does not pass through the origin. It shows that the gas pressure and gas temperature in degrees Celsius are linearly related. The result also shows that the gas pressure becomes zero at a temperature of negative 273 degrees Celsius. As the gas pressure cannot decrease anymore, the scientists started to believe that negative 273 degrees Celsius is the lowest possible temperature. They even repeat the experiment with different gases, hydrogen, oxygen, nitrogen, and so on, and with different amounts of gas, and they still get the same result, that negative 273 degrees Celsius is the lowest possible temperature. A. The Kelvin temperature scale. The scientists introduced a new temperature scale. They defined that negative 273 degrees Celsius to be zero temperature in unit of Kelvin, and it is called 0K. The freezing point of water, 0 degrees Celsius, is now 273K, and the boiling point of water is 373K, and so on. This new temperature scale measured in Kelvin is called absolute temperature scale. B. Pressure law. In this way, the pressure-temperature graph becomes a strict line passes through the new origin, and therefore the gas pressure is directly proportional to the gas temperature in Kelvin, the absolute temperature. This is the pressure-temperature relationship. It is also called pressure law. For the ease of application, we express it as P over T equals to the constant, or P1 over T1 equals to P2 over T2. Example 4. Pressure inside light bulbs. The initial temperature, pressure, as well as the final pressure are all given. Always remember to convert all temperatures to absolute temperatures. Then we may apply the formula above to find the final temperature required. Do check point 3 below.